Good day, students. Welcome to part 3 of the installment of the edexcel GCE Core Mathematics 1 for January 2012. We're going to be going over questions 5 to 6 in this installment. So let's go ahead and take a look at question number 5. It says the curve C has equation y equals x times 5 minus x, and the line L has equation 2y equals 5x plus 4. Use algebra to show that C and L do not intersect. So if we want to find out if two lines intersect, what we do is we set them equal to each other and find the solution to that equation. All right. But if we set these two lines equal to each other and there's no solution to the resulting equation, then the lines do not intersect. Okay. So for the A part, what we're going to do is we're going to set C equal to L and try to solve. Okay. If there are no solutions, then that means that no real solutions, then that means that there are no intersections. Okay. So how can we make that equate? How can we set them equal to each other? Well, if you notice that y for line C, y is equal to for line C we have y equals x times 5 minus x, and then in line L we have 2y is equal to 5x plus 4. We can set them equal to each other that easily because we have, oh, this is just a y and this is a 2y. Okay, so there are two ways we can make this happen. We can just double this. If we double this, then it will be possible to make them equal to each other. So for line C, I'm going to double line C, multiply both sides by 2, the left side and the right side, multiply by 2. So we're going to have 2y from line C equals 2x times 5 minus x. Okay, now I'm going to set 2y for line C equal to 2y on line L. So that will give me the equation 2x times 5 minus x equals 5x plus 4. Okay, now we're going to let me simplify this equation as much as I can. Let's see what we have. All right, if I distribute this 2x to both terms in the parentheses, we'll have 10x minus 2x squared equals 5x plus 4. Okay, it looks like we have a situation here of a quadratic equation. So in order to solve it, we have to put it in standard form first, or set it equal to 0 and then solve by using the quadratic formula or factoring. Okay, so let's set it equal to 0. So to do that, I'll subtract 5x from both sides, and then I'll subtract 4 also. So if I write this in standard form, I'm going to have negative 2x squared plus 10x minus 4 equals 0. Okay? Actually, it's plus 5x. I'm changing the middle sign. It's supposed to be plus 5x. Alright, so plus 5x minus 4 equals 0. Okay? Alright, so now, does this quadratic equation have real solutions? Now, the quickest way to check if a quadratic equation has a real solution is to examine the radicand, the value of the discriminant. Sorry. So we know that a quadratic equation is, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so that blue piece right there, that's the discriminant. Okay, if the discriminant is b squared minus 4ac, if it is less than 0, then that means that there are no real solution. Okay, so let's find a discriminant here and compare it to 0 to see if we have real solutions. If it's greater than or equal to 0, then we have real solutions. All right, so let's look at this scenario. In this case, we know that a is negative 2, b is 5, and c is negative 4. Okay, so I'm going to plug in these values into my discriminant expression, b squared minus 4ac, to see if there are real solutions. If there are real solutions, we're going to go ahead and find them, and that will help us find out where they intersect. Okay, so let's make the substitution. We're going to have 5 squared minus 4 times negative 2 times negative 4. When you work that out, you're going to have 25 4 times 4 is 16 times 2 is 32. Minus times minus is a plus, times a minus is a minus, so minus 32, and that gives you negative 7. Negative 7 is less than 0, so that means that there are no real solutions. Okay? There are no real solutions. So you know what this means? This means that line C and L do not intersect. Line C and L do not intersect. Because we couldn't find real solutions to the equation that resulted as a result of setting the two equations equal to 0. Alright? Okay, now let's move to the B part. The B part, we're asked to sketch the graph of C and L, showing the coordinates of points at which C and L meet the axis. So we have to show the coordinates where each point meets each axis. Okay? So let's go ahead and do that. Alright, so I have myself a nice little grid here that I'm going to use to generate the graph of the curves. This is part B, 5B. So the first, we're going to graph both of them on the same coordinate system, okay? So the first graph I'm going to draw is a graph of line C, okay? So let's start with line C. So for C, we know the equation for C is y equals x times 5 minus x, okay? So this tells me that it has two zeros. The zeros are x equals 0 and 5 minus x equals 0. If I solve them, this is already solved. If I solve this, I'm going to have x equals 5. So it cuts the x-axis at 0 and 5. Okay? So this goes my first point of intersection, and put it in green. First point of intersection. And then the next one is at 1, 2, 3, 4, 5. 0 and 5. Okay? So what is the concavity of this this quadratic function? Is it concave up or concave down? So let's expand that. That will help us determine whether it opens up or down. So if I distribute this x to these two terms, I'm going to have 5x minus x squared. If I write it in standard form, we'll have negative x squared plus 5x. Since the highest degree term, the square degree term, is negative, that means it's going to be opening downwards. Okay? So it's going to be concave down. So the graph of C is going to look something like this. It's going to look something like this. Something opening downwards. Okay? So this is just a sketch. Alright, let me try it again, make it look a little bit nicer. So let's make a parabola like this. Opening downwards. It intersects at this point, 0, 0, and then at that point right there. Okay? Alright, let's go ahead and indicate the coordinates, because the question asks us for the coordinates of each intersection. So this point right here is 0, 0. And then this point right here, the other x-intercept, is 5, 0. Alright? Okay, let's go ahead and graph line L. I'm going to erase this work right here. Line L is given by the equation 2y equals 5x plus 4. Okay? Since they specifically want us to state the intercept, we might as well use the intercept to graph this function. Okay? So if you want to graph using the intercepts, all you do is you set each coordinate to 0 and find the resulting coordinate. Okay? So I have x and y. I'll set x to 0, find y, and then set y to 0 and find x. And that will help me graph the curve. Okay? So when x equals 0, we have 2y equals 5 times 0 plus 4. If I work this out, I'll have 2y equals 4, which implies that y equals 2. When x is 0, y is 2. 0, 2 is going to be my first point. So 0, 1, 2. That goes the first point for line L. The second point I'll get when y is 0. Okay? So when y is 0, it's going to give me the equation 2 times 0 for the y equals 5x plus 4. Okay? So 2 times 0 is 0 equals 5x plus 4. Subtract 4 from both sides and divide by 5. So we're going to have x equals negative 4 over 5. Okay, so negative 4 over 5 is the x-intercept. All right, so negative 4 over 5. All right, so negative 4 over 5 is going to be somewhere here, right there, not completely 1. All right, and then we'll go ahead and draw the graph of line L, which is basically a straight line. Okay, so you can just draw it like that. And you can see from our graph, even though it's not perfect, they do not intersect. Okay, so there goes the graph of line L. So I'm going to go ahead and state the values of the intercepts, the x and the y intercepts. Okay, so for this is so forget this is line L. Okay, this is L. So for L, the x-intercept is given by the coordinates 0, 2. Okay, and then for the y-intercept is given. Oh, I'm sorry, I think I got it reversed. The x-coordinate is negative 4, negative 4 over 5, 0. So negative 4 over 5, 0. And then the x-intercept is 0, 2. Okay? So this one is 0, 2. All right, just using these 2 points here. Okay? So there goes the graph, and there goes the indication of all the intercepts. Okay? So there you have it. All right, so for question number 6, we're given 2 lines. For the A part, we have to find the gradient of line L1, assuming given that the equation is 2x minus 3y plus 12 equals 0. Okay, so for part A, the gradient is the slope. Okay, the gradient is the same thing as the slope of a line, and that's m. All right. If the equation is in standard form, the slope can be found by evaluating the expression negative a over b. Okay, that helps you find the slope. Okay, so in this equation, what is negative a over b? We know that 2x minus 3y plus 12 equals 0. So that tells me that this is a, this is b, and this is c. So if I want to find m, I just need a and b, right? So m, which is negative a over b, is basically negative a is 2 over b, which is negative 3. Let's not forget the sign there. So the slope m is 2/3. Okay, so the gradient of L1 is 2 over 3. All right, so that's that for part. All right, so let's go ahead and look for part B. Part B says we need to find the equation of L2. So let's go ahead and do that, the equation of L2. Well, we need to remember that the slope of L1 is 2/3 because that's going to play a part in determining the equation of L2, okay? So this line has a slope m of 2/3, okay? So if we want to write down the equation of a line, we need 2 things. We need a point and a slope, okay? So let's first of all find the value of this point right here. If I can find the value of this point, then I can use the fact that these 2 lines are perpendicular to determine the equation of this, to determine the slope of this line and hence the equation, okay? So let's find the coordinates of this point. What are the coordinates of this point? To do that, I'll just simply utilize the fact that the equation of L1 is 2x minus 3y plus 12 equals 0. So from L1, we have 2x minus 3y plus 12 equals 0. I need to find the y-intercept, okay, because I know at this point at the y-intercept, my x-coordinate is 0, okay? So if my x-coordinate is 0, I can plug that into this equation, and whatever the resulting y value is, that's the y-coordinate of this point right here, okay? So to find the y-intercept, we set x to 0, so we have 2 times 0 minus 3y plus 12 equals 0. Okay, now we need to find what the y-coordinate by solving this equation. So 0 times 2 is 0, minus 3y plus 12 equals 0. Subtract 12 from both sides and divide by negative 3. You're going to have y equals positive 4. Okay, So y equals 4 is your y coordinate of the point or your y-intercept, okay? So this value right here is 4. All right, now we have the point. So we have a point, which is 0, 4. I'm going to call this x1, y1. If I want to find the equation of this line, I need to find the slope, okay? I need to find the slopes. I already have a point, I need a slope. So in order to do that, I need some information, okay? So you're told here that L2 is perpendicular to L1. Okay, if L2 is perpendicular to L1, then that means the slope of L2 is going to be the inverse or the negative reciprocal of the slope of L1. Okay, because this line is perpendicular to this line. We already determined that the slope of L1 is 2/3, so we can use that to find the slope of L2. So the m of L2, or the gradient of L2, is equal to negative 1 over the gradient of L1, which is 2/3. Okay? Now, since dividing by a fraction is the same thing as multiplying by the reciprocal, so I'm going to reciprocate this and multiply by the numerator times 3 over 2. So negative 3 over 2 will be the gradient of L2. So the slope of L2 is negative 3 over 2. Okay? Now we're going to use the point slope equation of a line to determine what's the equation of my L2 is going to be. So the point slope equation of a line is basically y minus y1 equals m times x minus x1. Okay? y1 is 4 right here. So I'm going to plug that in here. And then x1 is 0. Plug that in here. So that's going to give us the equation y minus 4 equals m is 3 over 2. Negative 3 over 2, that goes here. Equals negative 3 over 2 times x minus 0. Okay? Just simplify a little bit further. We have y minus 4 equals negative 3 over 2 x. Okay? So that is the equation of L2. All right. Now, we're asked to find the area of triangle ABC. So let's go ahead and find that. Let me write down the equation of this line here real quick, since that's important. So the equation of this line is y minus 4 equals negative 3 over 2 times x. All right, I'm going to erase everything, and then we're going to go ahead and look for the area, okay? Now, we have to remember that the geometry formula for area, there are two ways we can do this problem. We can use similar triangles or just use geometry. I'm going to use geometry here. So this is my triangle. The area of a triangle, as given by the formula, 1/2 of the base, the length of the base times the perpendicular height from the base, okay? So in this triangle, from this point to this point, this segment right here indicates the height, okay? The height of my triangle, so that's h. This is what h is, and it's convenient because we already know what h is. We know that h is 4, okay? H equals 4 because from 0 all the way up to 0, 4, the y displacement is 4 units, okay? Now, to find the base of my triangle, I need to compute the length from here all the way to there. That entire length represents my base, okay? So from here to here. You notice this is the displacement in the x direction that helps me compute my base, all right? So all I need is the x coordinates here. I'll just subtract the x coordinates here, and that will be that, okay? So all I need to do is I need to find the x-intercept of the two lines, okay? All right, so let's start with the x-intercept of L1, okay? X-intercept of L1. To find the x-intercept, that means that y is what? Y is 0. So to find the x-intercept, you simply set y to 0 for L1, okay? The equation of L1 was given to us earlier here, so we're going to use that. 2x minus 3 times 0 plus 12 equals 0, okay? So we need to solve this for x. So we have 2x plus 12 equals 0. subtract 12 from both sides. 2x equals negative 6. Oh, I'm sorry. 2x equals negative 12. And then divide both sides by 2. You're going to have x equals negative 6. Alright, so that's the x-intercept. So in this point right here, this point is going to be, the value of this point, this is negative 6, comma 0. Okay? Now we need to find the y-intercept of L2, and that will help us determine the length of the base. Alright, so I'm going to divvy down the center. We want to find the y-intercept of L2. I'm sorry, the x-intercept of L2. Okay, so to find the x-intercept of L2, same procedure, we're going to set y equal to 0 in the second equation, the equation that we found, which is this one right here. Okay, so we're going to plug it into the equation y minus 4 equals negative 3 over 2x. We're going to set y to 0. So we're going to have 0 minus 4 equals negative 3 over 2x. Now to get x by itself, let's just subtract this first. We have negative 4 equals negative 3 over 2x. To isolate x, we just need to get rid of this negative 3 over 4. Alright, so what we'll do is multiply by its reciprocal. Right, so multiply by negative 2/3 on the right, and then multiply by negative 2/3 on the left. Right, these ones neutralize, divide out to 1, and if you multiply this, you're going to get positive 8 over 3 as your x-intercept. Okay, so the x-intercept of this piece right here, this point, is 8 over 3, comma 0. Okay, so to find the b's, we just simply subtract the x's, the bigger one from the small one. So b is basically 8 over 3 minus negative 6. That is the entire length from here all the way to here. Just simply subtract the x coordinates. Okay, all right, so if you do this, the base is going to be 8/3 plus 6. We'll put this over 1, find the LCD. We're going to have 8/3 plus the LCD is 3, so I times it by 3 top and bottom. So it's going to be 8/3 plus 18 over 3. Okay, which equals 26 over 3. That's the length of the base. Alright, now we have everything we need to find the area. So the area is going to be 1/2 times the base, which is 26 over 3, times the height, which is 4. Okay, if we work this out, 2 goes here once, 2 goes here twice. 2 times 26 is 52. 52 over 3 is your area. So the area of the triangle is 52 over 3 square units. Okay, so there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel so you can get updates to the next parts of these series, getting ready for the edexcel examination. More videos can be found on microsurf.com. Thanks again and have a wonderful day.